Okay, so let's continue our lesson on LeChatelier's principle. So before we said with concentration changes, if you have too much of something, so you add in some either reactant or product, the reaction is going to shift away from the side that you add it to. So if you add it to the right side, it'll go to the left. If you add it to the left side, it'll go to the right. And that's to consume that added. If you remove something from either side, it'll shift to the side that you removed it. So if you remove some from the right, it will shift to the right. If you remove some from the left, it will shift to the left. Now we're going to talk about changes in pressure. And most of the time, the way that pressure is going to have been changed is by changes in volume. So let's just do a quick review on a little gas law information, that if you increase the volume of a gas, remember, pressure will only be concerning our gas phase reactions, our ones that we use Kp for. But if you increase the volume of the container that this equilibrium is in, then the pressure will immediately go down. Okay? The problem is the system doesn't want to have that lower pressure. It wants to have whatever equilibrium pressure it had before. And so that's obviously a problem. But just to review, increasing volume decreases pressure. On the reverse side of that, if I decrease the volume of the container, the pressure inside the container goes up. And the problem is it's increasing the pressure of the whole system, okay, the balance that's there between the reactants and the products, and that screws up the equilibrium. So the system needs to reestablish that equilibrium. So it's much like the concentration one. You know, with the concentration one, if there was too much of something, the system shifts to bring it back down. If there's too little of something, the system shifts to bring it back up. Same thing with pressure. If the pressure's too high, like in this scenario here, if the volume was decreased and the pressure went up, the problem is the pressure's too high. The system needs to shift to decrease that pressure. Okay, so if the pressure's too high, the system's going to shift to decrease the pressure. And the way it does that has to do with how many moles of gas particles there are. So we are looking at this scenario right here. So if the pressure is too high, so it says here the volume was decreased, just like this one we were just talking about, the pressure will increase. So the system's messed up. What it needs to do is reduce the pressure. To reduce the pressure, it would then have to shift to the side with fewer moles of gas. Now you might be thinking, why do fewer moles of gas create less pressure? Let me draw a little equation here for you. Let's say we had an equation that was 2A plus B, and this is a gas, and this is a gas. It's in equilibrium with, let's say, C, gas. Okay, so all of them are gases. Over on this side, you have 3 moles of particles, and over here, we only have 1 mole of particles, because this C must be some big molecule made up of all these A's and B's. So if you were to envision this on a molecular level, like look at these 2 sides as boxes maybe, okay, you would have 3 times as many, can you give me some dots here please? You would have 3 times as many dots in this box as that box. I don't know if that's exactly 3 times, we'll go with it. This box here, there's more pressure being exerted, more particles hitting the sides of the container, and that's what pressure is measured by than over on this side. So if we were in this scenario that we were just talking about, but with this specific equation, to reduce the pressure, we need to shift to the side with fewer moles of gas. So what it's going to do is it's going to take these 2 A's and B's and shift to the right to make more C. Because the C, although it's a bigger particle, isn't as many particles, because the particle is comprised of all those atoms, and now it's going to make less pressure, and it's going to help bring that pressure back down. So again, if the pressure is too high, back up here, if pressure is too high, then the system needs to shift to reduce the pressure. So it shifts to the side with fewer moles of gas. Now, if we have the opposite, we have a system, it's at equilibrium, everything is wonderful, and then all of a sudden, boom, volume is increased. The problem is, as soon as you increase volume, pressure goes down. Now the system's not at equilibrium anymore. So since the pressure's too low, the system is going to shift to bring that pressure back up. The way it brings it back up is to shift to the side with more moles. Because if it shifts to the side with more moles and makes more of whichever side has more particles, then the pressure problem gets relieved. It brings that pressure back up to where it was supposed to be. So if we were still looking at this same scenario here that we had been looking at before of 2A plus B is in equilibrium with C, if we were wanting to shift to the side with more moles, we would have shifted to the left we would have made C decompose back into A's and B's, because now we'll have 3 times as many particles bouncing around in this container. So the idea of pressure and the idea of concentration are very similar. If there's too much, we need to bring it down. If there's too little, we need to bring it up. Now, how we do that, of course, depends on whether or not we're talking about concentration or pressure. For pressure, it'll be about either going to the side with fewer moles or going to the side with more moles. Let me show you what this looks like with some example problems that might help clarify a few things for you. So you see we have a balanced equation here at the top. And the first question says, if we reduce the volume, so the volume's going down, what happens to the pressure? So again, volume and pressure are indirectly proportional. So if we reduce the volume, then that means the pressure increased. Okay, and again, that's on this whole thing as a whole. This is an equilibrium. This is a container that has N2O4 and 2 NO2s in it. They're all in this container in whatever balance they've decided that they have. But now we've screwed up that balance because we've increased the pressure. So what's going to happen is, due to this pressure increase that we have to figure out how is it going to alleviate it. So again, the problem is that the pressure is too high. Think of that. Think of it that way. The problem is the pressure is too high. So what does it want to do to fix it? It wants to bring the pressure back down. So to bring the pressure down, it needs to shift to the side with fewer moles. So it's going to start to make more of the side that has fewer moles. So if we look at this equation, for this one in particular, we have a 1. So 1 mole of N2O4 is in equilibrium with 2 moles of NO2. So if it's going to shift to the side with fewer moles, it's going to shift to the left. Okay, it is going to shift to the left. It's going to make more N2O4, because N2O4 is only 1 particle, whereas the N2O2 side is 2. 1 particle will exert less pressure. So it's going to relieve this problem of pressure that we have. Okay, let's take a look at another problem. And I actually have 3 we're going to look at total, but let's look at this one. So on this side, on our reactant side, I have a total of 4 moles of gas. Remember, we are only looking at the gases. On this side, I have a total of 2 moles of gas. And again, this reaction is in whatever equilibrium for its pressure it's in. You know, we don't know what that is because we don't have that information, but we know it's at equilibrium. So then it says, if the volume is decreased on this system, which direction will the reaction go to achieve equilibrium? The first thing you have to do is remember what volume means. If volume is decreased, then that means that the pressure was increased. Okay, again, decreasing volume increases pressure. So the problem is that the pressure is too high. So the solution to the problem is to bring the pressure back down. So the way you're going to bring the pressure back down, remember we need the pressure to go back down, is we need to switch to the side or shift to the side that makes fewer moles of gas. So we look at our equation that we have here. The product side is the one with fewer moles of gas. So it's going to shift to the right. Your answer would be that it would shift to the right in order to produce fewer particles. So it's going to take 4 moles and turn it into only 2 moles. That's a win-win situation, and it brings that pressure back down. Okay. So again, if we are given volume, we need to figure out what that means to pressure, and then we can sort of go through this thought process. Now, the third practice problem gives you an interesting scenario. So I definitely want to take a peek at it with you. They tell you the volume's decreased. So again, decreasing volume means the pressure was increased. Okay. So when you go to look at it, you'd say, all right, well, if pressure increased, then it's too high of pressure. I need to bring the pressure back down, which means I need to shift to the side with fewer moles. Okay, that's what we want to get to, is the side with fewer moles. But you go to look. Here we have 2 moles of gas. Remember, again, we only care about gas. And here we have 2 moles of gas. So neither side has fewer moles. And what the answer to this question is it's kind of a trick question. I know you guys like to call questions trick questions, but this one really was. The answer to this one is that equilibrium wasn't disturbed in the first place. So if equilibrium wasn't disturbed, then it wasn't messed up, and therefore we don't have to fix it. If there are equal moles on both sides of gas, then changing pressure doesn't change the fact that our equilibrium, is what it is. So we just don't have to worry about it. Much like concentration, with these changes, although we're not calculating anything with this, these changes are going to bring us back to the same K value we had before. So it is going to re-establish, gosh, I'm doing some tough spelling words here. It's going to re-establish the same K. All right, it will re-establish the exact same K. That will be different for temperature, but for pressure and concentration, it's about getting back to the exact same K value. All right, so that's the information about pressure. The third video will discuss temperature.